or at least, it seems that way from my observations.
I still get a lot of requests to put the answers online after the tutorial.
Which is interesting because I never got that request.
This touches on, I can't remember who said this earlier, but it seems like, like the homework problems that we give to the students are always situations where you can use Gauss's law. And is it similar with this tutorial? Is it that every problem in the tutorial is something that you can use?
Yep.
Right.
So I think, like an important thing would be to put something in there that's going to make them have to stop and recognize they can't use it there.
I completely agree. I feel like when Steve described the key question that drives the tutorial, it's how do I use Gauss's law to solve for the E field? That's the question. Right. And that the question that this is assessing is not that at all. It's like, when and why would I ever use this thing? That's a different question. It's epistemologically a different question.
So add the question, draw 3 symmetrical charge distributions where Gauss's law doesn't help you find the E field.
Or just like, why doesn't this work?
Yeah.
Why doesn't this work? It's amazing. It's a different. I'm
in fact,
so interesting.
No.
So, suggestion, one option if you're thinking about building this into the tutorial, and I think Mike's point is really wise. You can't build this into the tutorial. This is how people are thinking about it. But in fact, you can build it into the tutorial. Now I'm not understanding what you're saying and disagreeing.
I think I disagree with myself after hearing Rachel's comments.
Which is to say, you could build in a nice LB pair, which is to say, hey, your intuition would lead you to think X, and to bring up one situation in an LB pair, and then another one that says, well, formal physics teaches us this. How is it that you reconcile these two different frames? Your intuition says, well, Gauss's law is always appropriate. You can use the sphere on the infinite plane sheet because you see the charges are evenly spaced, and you know that. Anyway, you think you can use it there. Your intuition would lead you to think that then that's applicable. Here's another situation which contradicts that. How is it that you resolve your intuition with these two things? Are you familiar with LB pairs that we talked about? So my favorite LB pair, for those who haven't heard about it, is you walk into a room where you've had a hot cup of coffee and an ice cube drink sitting for like 20 hours, and you say, because it's a grad lounge, and you're going to drink them, do you have to worry about them being at different temperatures? And everybody's like, no, they're at the same temperature. The coffee's gotten cold and the Coke's gotten warm. I walk into the same room and I put my hand on the table and it's nice and warm, and I put my hand on a piece of metal and it's super cold. By comparison, how is it that you resolve these two different intuitions or ideas about it? You can take that same idea here to the Gaussian surfaces. Those are known as LB pairs. It might be a nice exercise to bring people through. And he calls it refining intuition.
It's meta, though. Because you're really saying your intuition is to use a mathematical formula to solve for whatever it is. And this is saying you're making a judgment about its utility, given the job you have to pull off. That's what your intuition, that's really.
I would guess, it seems to me like what the theme I see again and again is just the misidentification of what Gauss's law says. Versus how it can be used, in practice. I think in some students' minds they're going to think, Gauss's law is only about solving for the E field in symmetrical situations, even if they know that it's always true, right? But I think they're confusing, what it is when we say, can we use it? Is Gauss's law true, and can it be used?
What do you mean?
Valerie didn't understand that.
Well, what I'm saying is that, so obviously, Gauss's law is always true, right? It's something that's, and if we know the E field, we can calculate surface integrals and things like that. And I think we're always talking about Gauss's law in the context of how can I use it to solve, for the electric field in symmetrical situations. And I think students, in their minds, are thinking, they're identifying that task as a reflection of what Gauss's law is actually about.
That's a different problem. That's an additional problem, not a different problem.
Yeah. Anybody else have other
question about, in all of this instructional thing, different things, is how much is flux being used to help or possibly hurt the situation? The notion of flux, which, if you're saying what is Gauss's law about, I mean, that left-hand side of the integral form, which is flux, right? So the question is that helpful, hurtful? Do we know anything about that in terms of how it helps with this, you know?
I think there's some information in the Singh article because flux is, in their course it seems flux is actually discussed, whereas in the junior level course we didn't even mention flux when we talked about Gauss's law. Well, we mentioned that term, but we didn't talk about really what it meant. So I think there probably is some information on that, but I don't know.
Did you talk about it in paradigms? Is it, I mean, I haven't figured out if it's helpful or hurtful yet myself.
I have to think about that. I don't think any more or less than in our course. It's not treated differently, the way symmetry was.
Another idea I had was explicitly address the issue of symmetry in lecture, which is something Steve, I think, did in his course and we didn't do in the 3310 course. And it did cause students, and explicitly address in what situations you can use Gauss's law. It seemed that it did cause students to make that kind of, make an argument about explicitly when you could use Gauss's law more. But I didn't notice students explicitly making symmetry arguments that much more. So I don't know if explicitly addressing this in lecture would help. I know we've already heard some of your ideas. Any others? All right. I think I may come back to these at the very end, but I think I'm going to change gears and talk a little bit about the tutorial pretests for a little while. So the goal of these pretests are to determine if the tutorials lead to learning gains. That's one goal. And expose student learning difficulties on a really fine-grained level, and expose them not only to us but to the students. Basically, they get asked questions related to the tutorial right before the tutorial, and then they can go sort of answer any uncertainties that they had or address confusions that they had in the tutorial right afterwards. And the way they worked was that they were weekly online pretests for 15 minutes, and they were available for like the 4 days coming up to the tutorial, and so everyone stopping right before the tutorial. So everyone, of course, did them in like the hour before the tutorial. Not everyone, but the vast majority of students did them online in the hour before the tutorial. And then they were post-test during the week reviewing. So in the week before the exam, the tutorial was a review tutorial, and so the online 15-minute thing, instead of being new questions, was old questions slightly tweaked. So that served as a post-test. And some of them were also asked again on the midterm exams or on the final. Charlie?
Yeah, so I was under the impression in the past these tutorials have been like optional, voluntary. I mean, so is that the case here then?
Yes, the tutorials are optional and these pretests are optional. They're worth a couple points extra credit each week. So there are people who come to the tutorial and don't do the pretest. There's people who do the pretest and don't come to the tutorial. So, but I just looked at, in the data I'm about to show you, I just looked at students who did all three, took the pretest, took the post-test, and also attended the tutorial.